Here's problem 26. If 25 kilograms of ice at 0 degrees Celsius is combined with 4 kilograms of steam at 100 degrees Celsius, what will be the final equilibrium temperature in degrees Celsius of the system? Let's imagine that we're going to be heating up the ice, and then we're going to be losing energy with the steam. So the steam will be cooling as the ice is heating up. We'll have a latent heat of fusion associated with the ice as it melts into water, and then we're going to heat up that water. Then we're going to have a heat associated with the condensation of the steam, and we're going to have a heat associated with the cooling of the steam. All this will equal 0 because we have a isolated system, so whatever is being warmed up is being offset by whatever is being cooled. Okay, in terms of the water, we'll have the mass of the ice times the latent heat of fusion plus the mass of the ice, the specific heat of water, times the change in temperature of the water, plus, now for the heat associated with the condensation of the steam, we can imagine that this would actually be equal to the negative of the heat associated with the vaporization of water, because it's going in the opposite direction. Another way to think about it is that we can think of this as the latent heat of vaporization times the change in mass of the steam. The final mass of the steam, if we're cooling down, is going to be 0 because we're losing all of our steam as it condenses into water. And so this would be equal to the latent heat of vaporization times 0 minus the mass of the steam, and that would give us a negative mass of steam times latent heat of vaporization. So this is going to be a negative mass of the steam, latent heat of vaporization. Another way to think about it is both of the terms associated with the steam are going to be negative terms because we are losing energy out of the steam going into the ice and the water there. So those are going to be negative terms where the ice terms are positive. So we also have the mass of the steam, the specific heat of water, and the change in temperature of the steam as it is in terms of water, and all this is equal to 0. Okay, putting in our numbers, we have the mass of the ice, which is 25 kilograms, which would be 25,000 grams. Latent heat of fusion is 80 calories per gram. Mass of the ice, 25,000. Specific heat of water is 1. Our change in temperature is going to be our final temperature minus our initial temperature. It initially was at 0. And we have minus the mass of the steam, 4,000 grams, times latent heat of vaporization, 540, plus 4,000. Specific heat of water, when the steam turns into water, is 1. And we'll have the final temperature minus the initial temperature of the water after it has changed phase, which would be 100 degrees Celsius. It's equal to 0. Divide both sides by 1,000. And let's simplify this and solve for t. So 25 times 80 will give us 2,000, plus 25 times t, minus 4 times 540 will be 2160, plus 4 times t minus 100 will give us a 4t minus 400. All this is equal to 0. So we're going to have 29t is going to equal 2560 minus 2,000, or 560. So our t is going to equal 560 divided by 29. What is that? 19.3 degrees Celsius. So in this situation, with the phase change of the steam into water, we're going to get a final temperature of 19.3 degrees Celsius, and also we have the phase change of the ice into water as well. So two phase changes going on. Final temperature 19.3 degrees Celsius.